Hello. Today we're going to work on lesson 2-4, the last section. This is an extra section for extra practice on page 183. And it's just to help build some concepts. And it says, if you're interested in weight loss, there certainly isn't a shortage of information, diet plans, supplements, and flat out gimmicks available to you. But the simple truth is this: gaining or losing weight ultimately comes down to one thing. If you consume more calories than you burn, you'll gain weight. And if you consume fewer calories than you burn, you'll lose weight. In this activity, we'll study some aspects of weight change. So it says Bubba weighed 170 pounds when he started college and never really thought about his weight too much. Then a funny thing happened. He got super busy, moderately poor, and started eating a lot of cheap fast food. He also started sleeping less and not drinking enough water. The result, he started gaining weight at the rate of 0.4 pounds per month. No biggie, right? We shall see. Write a linear equation describing Bubba's weight, y, in terms of x months. So he started at 170. That's his y-intercept. And he was gaining 0.4 pounds per month. So months is going to be our x. Restate your answer in this form. If x represents months, then y equals the weight, total weight, represents weight after X months. So if Bubba continues his modest sounding weight gain, how much will he weigh after 3 years? So because our equation is in months, we have to put 3 years into months. So that would be 36 months. So he would weigh, so he was gaining 0.4 pounds times 36 months plus the 170 that he originally weighed. Times 36 months plus the 170. So he would weigh 184.4 pounds. How long will it take our buddy Bubba to pass the big 200 at this rate? So his weight is calculated by this, and it says pass. So when will his weight be greater than or equal to, or pass means simply greater than 200. So that's what we want to find. So let's take a look here at Desmos. Okay, so in Desmos, I'm going to put in our equation y equals 0.4x plus 170. So this is what we have for our friend Bubba. And then I'm going to hit this graph. Oops, no, I'm going to hit the graph. And I'm going to zoom, oops, I'm going to zoom out. Okay, because there's Bubba. Okay. And then number 4 says we want it to be greater than 200. So I'm just going to put y equals 200. So it'll draw that line so we can look at the comparison. And this is where he actually starts to weigh 200, is after 75 months. So after 75 months, he is going to weigh more than 200 pounds. So 75 months, so 75 divided by 12 is about 6.25 years. So if we do 75 divided by 12 months in a year, it's about 6.25 years. So let's flip the page. They asked us to graph it, and we did. So 6 says find the slope and the y-intercept and what does it mean. So let's go ahead back to our paper here. And so our slope is the 0.4, and it's pounds per month. So he is gaining 0.4 of a pound per month if he keeps eating at the same rate and exercise at the same level or no level. His y-intercept is 0,170, which he weighed 170 pounds at the start of college. Okay. It says, now let's study what it takes to lose weight. It's generally accepted that an average person can lose 1 pound if he burns 3,500 calories more than he consumes. Let's say that after reaching the 200-pound plateau, Bubba has had enough and decides to work on losing some weight. The table shows his weight if a certain number of calories are burned. Find the slope of a line based on the data in the table. Use weight for y coordinates. So this is going to be our y1, because remember when we put in data, it's using x1 and y1 or x2 and y2. And thousands of calories as x coordinates. So this is the number of calories he's burning and the weight how much he's gonna weigh. So we're gonna go back to Desmos and put this into Desmos and have Desmos generate an equation for us because we like that. So we're gonna put in a table and I'm gonna name this here lesson 2.4, and this is Bubba's weight. So we have an x1 is going to be calories, so 0, 14, and this is in thousands, so 14,000, 28,000, 42,000, 56,000, and so on. Okay, and then his weight was 200, 196, 192, 188, and 184. Okay. So I'm going to go up here and I'm going to turn off my blue and my red equation from before. And I'm just going to show my dots here and I'm going to hit my magnifying glass to show my data of him losing weight. So he was at 200, 196, 192, 188. Okay. And then remember, to do a model, we have to use the tilde. So I'm going to say y1 and tilde mx1 plus b. And it gives me my model. And so here is my slope. I'm going to write that for number 8. My slope is m equals negative 0.286. And then I'm going to go ahead and write 9, and then we'll come back to my paper and describe it. So 9 is our y-intercept, and that's 0 and 200. Okay, let's go back to the paper. So let's go to our slope. So our slope is our change in y over change in x. And y, I'm doing this for my units. So my y units is pounds, and my x units is calories in thousands, right? Okay, so this is negative 0.286 pounds for 1,000, because this is 1, but it's in thousands. So 1,000 calories. So his weight decreases because it's negative slope, decreases 0.286 pounds for every 1,000 calories. Okay. Write a linear equation. Okay. So it is negative 0.286x plus 200 as our equation here. Okay, so number 10 says restate your answer. So we already said this. Y is his weight after X number of calories burned. Use your equation to find Bubba's weight if he burns 50,000 calories above what he consumes. So this is important. We have to remember this is above what he consumes. So because this is in thousands, right? Our data is in thousands. We have to take the 50,000 and divide by 1,000. And so this is 50 in for X. So we're going to go because our table's in thousands. So we're going to go back to decimals momentarily. And so I'm going to, you can do a couple of things. You can type it here if you wanted, or I'm just going to go to my line and I'm going to go to where X equals 50. So I'm getting close. Oh, I just passed it. So right there, about there it is. Oh, oh, right there it is. So 185.7. And we can round that up to 186. So approximately 186 pounds. 12 says, use your equation to find how many extra calories Bubba would have to burn to get back to his weight at which he started. So our goal is 170 pounds. Um, 170 pounds. And I'm going to just go in here in Desmos and write y equals 170. And then it will draw a line for me at 170 when I hit enter here. And I'm going to zoom back out. So it's 170. I'm going to go over here and see where the purple and the green meet. And that's at 105. So 105, we're going to go back to our table for a minute. Times 1,000 because it's got to be in thousands for calories. So, oops. So 105 in thousands. So that's 105,000 calories above what he eats total. Right. So this is after some months. According to the Mayo Clinic, a man of Bubba's size would burn about 755 calories from running for an hour. How many hours of running will Bubba need to put in to get back to his original weight? So he has to burn 105,000 calories. So 105,000 calories divided by 755. And we could write this as a unit conversion. So remember, we 105,000 calories times 1 hour is 755 calories. So our calories are going to cancel. So 105,000 divided by 755. And it will give us hours. So 139.07 hours. So he can set his goal with that. It says, based on this entire activity, what would have been Bubba's best approach when starting college? To watch what he eats and to get some exercise. So then he doesn't have to worry about it. That's what I say. 15, 16, and 17, we've already worked on before in some of these. So we can quickly read it and put it together. It says a movie downloaded service has a $14 monthly fee for membership and then costs $3 to rent each movie. If we model the cost Y of renting a certain number of movies in a month, what is X? What is the slope of the line and what does it mean? So the cost Y is going to be $3 times each movie plus the $14 fee, right? So the slope is $3 per movie rented. The y-intercept is 0.14. We've done this a lot. And it's the monthly fee we pay. And then we already said our equation is this. So there's the extra problems about Bubba. And have a great day. See you back for lesson 2-5.